a little bit of background about me. I've been working in tech startups for almost 10 years now. Started with computer vision at a French startup called Moodstocks that got acquired by Google. And then I've been at a bunch of different startups. Most of them failed. Some of them got acquired. And I started Hugging Face 3 years ago now. So a little bit of background about Hugging Face. We're a startup based out of Dumbo. We raised a bit more than $20 million from Lux, BetaWorks, so a lot of like New York investors and some Silicon Valley investors like A Capital and some fun angels like Kevin Durant before he moved to New York and the hat. And basically at Hugging Face, we're mostly known for having built the most popular open source NLP library, which is on GitHub, that is called Transformers. We also built a couple of like other open source projects. We've been lucky to have been mentioned in more than 700 research papers for the last 15 months. And we have more than 1,000 companies using our library, from a medium-sized one like Monzo, for example, the banking one, to really large ones like Bing or Apple. And we also built a couple of like really fun demos of NLP that you should really check out. For example, one of them is Write with Transformers, which is kind of like a Gmail autocomplete, but way more creative and way more fun than Gmail can be. So here, for example, like it can even help you think about the meaning of life. So like the first part is what you're putting as an input, and then it's generating the end of the sentences for you. But enough about me, enough about Hugging Face. I wanted to use this talk to state a point. I don't know how controversial it is. It depends a little bit on the audience. But I think it's a point important to make. I believe that NLP today is the most important field of machine learning. It's something that you don't always see by looking from the outside for multiple reasons. Computer vision was way earlier than NLP. A lot of the other fields of machine learning are pretty good at like showing and demonstrating. Obviously, you're seeing like a lot of computer vision, a lot of GANs, a lot of like robotics, a lot of self-driving, which are producing really, really impressive demos, which is sometimes harder to do with text. But it's important to understand a little bit what's happening with NLP these days, because I think it's really, really transformational. And I want to start maybe to know how many people in the room knows what NLP is. Can you raise your hand if you know what NLP is? All right, that's good. And how many people in the room has built over the last 2 years NLP technologies? Can you raise your hand? Cool. Some people, that's great. So as most of you guys know, NLP is a branch of artificial intelligence that is related to understanding natural language, right? And natural language, as opposed to, for example, code, or as opposed to structured data, is what I'm using to talk right now. And if you're taking some distance and think about your day today, you realize that most of it is spent in natural language. Obviously, I'm talking to you now in natural language. You'll mingle after in natural language. Obviously, all this communication went online in natural language. So you're going to send text, you're going to send emails, you're going to use Slack in natural language. You're going to read the news, read books in natural language. Even activities that you wouldn't think of purely natural language, like, for example, watching movies, they don't make any sense if you remove the dialogue. And when you think about companies, they all also built around natural language. Obviously from customer support, sales, everything related to the customer. So when they leave review, internal, external communication, meetings, the way you present your company. It's kind of like a summary, natural language is really the interface of humans, obviously. And so all the humans' activities are built around natural language. And something that has happened over the past 2 years is a very big technology switch when it comes to natural language processing. There have been a couple of kind of like long-term trends. Obviously, compute that is getting bigger, better, cheaper. The emergence for the past decade of like the largest open data set, which is basically the web. And the last kind of like missing piece to this puzzle for us is transfer learning, with the reference paper on the subject that came out a bit more than 2 years ago, called "Attention is All You Need." And as a kind of like high-level, simplistic way, that's what made deep learning for NLP finally work. And the way it works, if you want to understand a bit better, is that you basically take large internet data sets where you do what you call pre-training on a specific task. For the current models, it's something called language modeling. So you try to predict in a sentence the next word or the missing word. And that's how the model mostly is learning about natural language. And then you're able to fine-tune with really little labeled data on any kind of specific NLP tasks that you want to use it for. So you can fine-tune it on any kind of classification, any kind of information extraction, any kind of generation that you're interested in. And what these kind of like new kind of models did is that they started to basically completely destroy all the previous science benchmarks and really kind of like generate this immense kind of like progression on the science side. So for example, here it's like the progression on a benchmark called GLUE, which is an aggregate of different natural language processing tasks over the past 15 months, from like May last year to June 2019. And what's like interesting to understand the scale of it is that the human baseline, which means having humans do exactly the same tasks, is just below what we reached in June last year. Obviously, I'm not telling you that we are at human levels for all NLP, but just the fact that on a specific benchmark, on a specific domain, on a like small evaluation, you can reach human level compared to where we were just a few months away, is really mind-boggling. And you could say like maybe that's just this benchmark. It's mostly classification, so you could say maybe it's just an easy task. But this is, for example, the progress of the state of the art in question answering with a benchmark called SQUAD. And the funny thing for this benchmark is that when it started to grow so fast and basically go to 90% accuracy, people were like, all right, the benchmark is shitty, it's too easy, we need to change it. So they basically worked on a second version of the benchmark called SQUAD 2.0, and that's what happened. It basically took like 6 more months to get adjusted and then climb the same way it did on the first benchmark. So we're really moving from a world where only humans could do natural language, which is why you have such large customer support, sales, community communication departments in companies. If you think of it, these are really natural language processing departments. That's what they do. And we're moving from a world where only humans could do natural language to a world where now algorithms can do it too. They're finally able to classify, understand, generate natural language the same way humans do. And you could be like, all right, that's a science thing. That's the science thing. It's going to take like a decade to get into in production. The really interesting thing here is that most of the intelligence is in the models, and the software engineering layer on top of these models is really thin, which basically led these models to go to production really, really fast, right? If you think of it, the science is just 2 years old, and just with our example, we have thousands of companies using it in production today. I'll give you a couple of examples. One very common example is text classification. So you'll take, for example, Monzo, who's receiving like thousands of customer support emails every day. They're using these models and this new research to classify them and know how priority it is, how the sentiment of it, or like which department it refers to be able to route it to the right team. Obviously, there are like many other applications in text classification, from detecting spam, from detecting bullying, from doing moderation that you're experiencing basically every day without really knowing it. The other really big use case is information extraction. So for example, you have a platform called Chegg, which is a homework and notebook platform. With these models can now extract information directly from text. So obviously here understanding that Washington is not the city, but the person extracting the dates or extracting topics from the homeworks. Another really big application of these models is question answering. So if you go on Bing today, or if you go on Google and you ask a question in natural language rather than relying on keywords, they are going to use that in production today. Google did a lot of PR a few months ago saying that moving to these new transformer models has been one of the most impactful changes that they've done over the last 5 years, if not since the beginning of Google. Another really big application is text generation, text summarization. We've probably all used it in Gmail when you have like autocomplete. Some people are using it to generate articles when the share price is moving. Some people are using it like Bloomberg to do summarization. And the last one is obviously probably the most popular one in terms of like public view on it, conversational. So obviously Siri, Alexa, Square, for example, uses transformers to power their customer support chatbots. And these are really kind of like just a couple of like examples. There are like thousands of them out there today. You can't spend any day without knowing it, usually using a product that leverages these new NLP model. And what's really cool is that we're seeing this very positive loop where the more companies are using it in production, proving the impact of them, proving the ROI of them, the more they're confident to invest in science. And the more they're investing in science, the faster it goes, and then the more the science progresses, obviously, the more the usage can grow. So we're seeing this really positive loop. So basically, you've understood that I'm really excited about NLP, and I want you guys, if you need to remember just one thing from my talk, is that if you haven't worked on NLP for the past 2 years, or if you've never worked on NLP, take a look at it, because like we've made so much progress. It's really exciting what's happening in the field now. You won't be disappointed by trying the new NLP, which is really different than the NLP from a few years ago. So try it. You'll see it's really exciting. Yeah, happy now to take questions.
Thank you. Very nicely done. So why do you think your open source project has been so successful? So clearly there's the timing and NLP becoming a really important thing. Any other sort of like lessons or tricks that you may want to share with the audience?
Yeah, I mean, I think in the current world, there's like a part missing between science and engineering, especially at big companies where you have these huge science departments that are doing really cool stuff. And on the other side, you have these huge engineering departments that are doing really cool stuff, but they don't talk to each other, right? So we're filling this kind of like gap in between where we're releasing state-of-the-art models produced by the science, but that are engineers friendly. So I think that's the main gap that we're filling with obviously a strategy which is open research, open source by default, that is setting us apart from most of the people who are either like doing closed source or not real open source, which is more kind of like releasing something and forgetting about it, which is not what most of the companies need when they need to use open source.
Okay, very interesting. I have other questions, but I want to open up.
Hi, thanks for your talk. I have a question about, obviously your NLP models aren't going to be able to detect everything. What's your approach for retraining it with utterances that may map to like a fallback intent, for example?
To a what?
To like a fallback or intent or something your model doesn't recognize. Like there's going to be phrases or utterances that map to that. What do you do with those utterances?
So it's a case by case, the companies that are using our open source usually set up their own training. And so like depending on their use case, depending on their industry, depending on the level of accuracy that they need, they will set up their own mechanisms to make sure they can account for false positive, false negative, or account for mistakes.
Really interesting stuff. I've noticed the improvement in the benchmarks as well, and I wonder if you have any predictions about either the commercial impact of this over the next, say, 2 years, or the performance improvement that you might expect over that period.
Yeah, I believe that in 3 years, every single company in the world will use NLP. And even more than that, I believe that in 3 years, a company that is not using NLP will be in a systematic disadvantage compared to a company that is using NLP, because it means that the company won't understand their users, their customers, their employees the same way a company using NLP would. And in terms of kind of like progress of the science, in terms of like a benchmark, I really think that we're just at the beginning of it too. Because if you talk to people, if you dig, you realize that we're still kind of like doing black magic in a way. We're still at the very beginning of understanding what works and what doesn't work. A good example of that is that we've been working for a few months on a research project around sparse transformers. And there have been some research around what is called the lottery ticket. And people are starting to realize that in a neural network, you can remove some layers completely randomly and keep most of the performance. Some people are thinking that, like a majority of layers of a neural network today is completely useless. So it gives you kind of like an idea of like how early we are in understanding these things. Yeah.
Thank you. Your library is really good, and great job on Distilbird. I actually have a question as far as how you plan to maintain the library, and what is the ways you guys plan to generate revenue? Because I know having a pure open source product out there, it's not easy. It doesn't transfer to dollars.
Yeah, we've been lucky to have really supportive investors so far. As I said, Lux, BetaWorks, A Capital, and a bunch of angels who luckily believe in the long-term vision of the value that you create if you have the NLP technology that every single company in the world is using. So we haven't had the constraints to work on monetization yet. So we're making zero revenue, which is pretty interesting for a company our size and our stage. Luckily, we now have a lot of examples of open source companies that managed to find a really good business model. Matt talked about Mongo with the CEO coming to this meetup in a few weeks. Is obviously a good example. You have hundreds more now, especially in New York, actually, with people like Elastic, for example, which is also another good example. So there are plenty of kind of like examples, plenty of like different ideas we could and we will explore in the future. For the moment, our main priority is to stay the most used open source NLP library and expand our adoption.
One more French CEO.
Say in French. Congrats
in French.
So you hear a lot of people saying that you can't compete with the big players, Facebook, Microsoft, Google, because they have so much data and they've hired all the top people. Do you think they're actually ahead of you and you don't know it because they don't release it? Or you think that you've actually better than them? If you are better than them, how can you explain how you get to be better than these people who have all this data and all these resources?
Yeah, I agree. You can't compete with these guys if you're doing the same thing that these guys are doing. We've taken a different approach by really focusing on the open source approach, which they're not really taking or not seriously in NLP. So that's how we compete. And thanks to the open source, we actually managed to gather a really, really strong community of people contributing. We basically started to be the standard for NLP. So now every new models that will come out, the researchers are usually either building their models inside our library or will integrate it themselves, right? So that's why we always at the state of the art on our libraries. That's why we have maybe models that you've heard of, GPT-2, BERT, ExcelNet, all these state-of-the-art models for NLP. So we believe that actually if all the other companies than Facebook, Google, Apple, Amazon are actually all contributing to the same open source technology, they can actually end up with something way better than each one of these guys could build. So that's kind of like our thinking around it.
Great. On this note, thank you so much. By the way, amazing shoes, branded.
Thanks.
With the logo, very, very nice. Thank you. Congratulations on all the success.
Thank you.